Okay. Now we will be doing problems on this chapter, fluids in motion. Formula and all you know, we start straight away. Page number 412. Page 412. Question number 1. Water entering a hose flows with a speed of 0.10 meter per second through a pipe of 21 millimeter inside diameter. What is the speed of water at a point where the pipe tapers to a diameter of 7 millimeter? You have to find the speed of water where the diameter becomes 7. It was 21, now it becomes 7 millimeter. You have to find the speed there at when the diameter of the pipe becomes 7 millimeter. So for this question, we will be doing like this: A1 V1 is equal to A2 V2. Equation of continuity. Area formula we write pi r square, pi r1 square. V1 is equal to pi r2 square V2. Pi and pi will go. First case diameter is like 21 by 2 square. Radius is 21 by 2. V1 is given. This speed is given 0.1, 0.10. R2 is given 7, right? 7 by 2 square into V2 we have to find. Now find the answer. These two can cancel. 7, 3 will go. The 3 square is coming 9. 9 into 0.10 is equal to V2. Therefore, the value of V2 will come 0.9 meter per second. Answer. You can have 0.90 or 0.9 is answer. That is where the diameter is less, speed is more. It was 0.1, now the speed becomes 0.9, so increasing by 9 times. That is answer. Okay? Have you understood?
Yes, sir.
So,
Okay, now we are doing next one. Question number 2. Question number 2. What is the speed at which water flows from a small hole 3 meters below the water level in a full tank which is 5 meters high? Okay. What is the speed at which the water will flow from a small hole? Water coming out through a small hole is called efflux velocity. You can write like this. What is the formula? V efflux. V reflex formula is root 2 G H, small h. I'll put the value here. 2 G value is not given here. I'll take 10. Tell me what is the value of h here in this question. What is the value of h? What is the value of h? What is the value? How much value you should take for h?
sir, h minus 5, no?
The value of h in this formula, the value of h is the depth of the hole from the liquid surface. What is the depth or height of the hole from the liquid surface? It's already given 3. We'll add 3 out here. You have a container here. Hole is here. 3 meters from water level. Where is the water level? This one from water level to hole. How much ever? This is h. Total height will take as capital H. The total height is capital H. So they have given total height is given 5 meters and the hole is situated at a height of 3 meters from the water level. So we will take this one and direct 3. Don't take 5. 5 is given just to create confusion in your mind. Your answer will come how much there? See, root 60. Find the answer of root 60. That is answer 7.67 meters per second. Is answer. Okay. Okay. Say okay or not okay. If you say that. Okay. Now, by the way, now I am Teachment teacher. Okay. Can you see the logo here?
Yes, sir.
Sir.
This is yeah. This is gifted by Teachment to me for taking classes. I complete 100 hours on Teachment, so they have given me this gift.
Are
You
they?
are Teachment student
Good
now.
job, sir.
You are Teachment student now.
Sir,
Okay.
chick.
Rakshik. Okay. Now we'll do the next question. Huh? This one is done. Now we are doing next question. See, one topic they have removed from the syllabus, so that part we don't have to do. That in this exercise, number 3, number 4, number 5, no need to do. 3, 4, 5 is out of syllabus. We can cancel them. 3, 4, 5, and number 11. Number 11, no need. 3, 4, 5, and 11, no need. It is not in the syllabus. There is a formula called Poisson's formula. It is not in syllabus now. So now I'll give another question. Okay. Now the question is here. Right. Water flows. Water flows. Water flows. Water flows through a horizontal pipe. Water flows through a horizontal pipe of varying cross section. Varying cross section at the rate of
Sir, can you repeat?
10 meter cubed. Water flows through a horizontal pipe. Water flows through a horizontal pipe of varying cross section. Varying, VARYNG, varying cross section. Varying cross section at the rate of 10 meter cube, 10 meter cube per second, 10 meter cube, 10 meter cube per second, 10 meter cube per second. So find the velocity at a section, find the velocity at a section where the radius of pipe is 10 centimeters, where the radius of pipe is 10 centimeters. Radius of pipe is 10 centimeters. Yes. So this time the rate of flow is given. What is the rate of flow given? 10 meter cube per second. Rate of flow is capital V given. This question is from page number 405. Page number 405. Example 23-1. 23-1. Capital V formula we have A into V. Right like this. Capital V is given 10. Area will take, area formula will become pi r square into V. Writing 10 as it is pi. Radius, what is the radius given? 10 centimeters. Change in meter, you get 0.1 square into V. Find the value of V. The value of V comes 318.5 meter per second. Finished. Finished. Done. Okay?
So you just took everything
All right.
that's right, no? Please clarify your question. So you just took everything that's right and calculated, no, sir?
Huh? You're not asking. Next question. Next question. We have to find this distance where the water will be striking the floor. This distance is R, range. I think I have given you the formula if you remember. Please check. Range formula is actually what? If you don't know, the range formula will come like this. Velocity into time. Time formula is like to this height, from here till this height. Height above this one, from here, this height is falling. This height value will become h minus h. I write like this, h minus h by g. Projectile motion chapter, I have done this. V values, flux velocity formula we got 2gh. And here you write 2 capital H minus small h by g. G and g cancel. 2 and 2 will come out. And here your answer will come as h minus h into this. Choose this option, option B. Answer for this question is option B. Done? Option B.
No, sir.
What no? You did not do, huh?
Sir, doing.
Check yesterday. Yesterday I had done it. It was done yesterday. I mean, it should be there in your copy. Now tell me, done? So which is the correct option? Option
Sir,
B.
done.
Okay. Now next question number 9. Just
Sir,
below
can you
that.
explain this
Question number
again?
9.
Sir,
What to explain? See yesterday's note.
Sir, that-
Yesterday you were there. Were
Yes,
you
sir.
there yesterday? Please
Yes,
check,
sir.
check. If flux velocity below that, I had done all this yesterday. Check. Can you see yesterday's thing? Notes. Yeah, tell me now. Have you understood or explain again? Huh?
So understood.
Okay.
yes, sir. Okay.
Next question number 9 now. Just below that, question number 9. Please see question number 9. A water tank resting the floor has two orifices A and B vertically, one above the other. The orifices are at a height h1 and h2 as measured from the floor. If the jet emerging out from these orifices hits the floor at the same point, then the height of water in the tank is. Okay. I understood the question, I'll explain. Question says there is a tank, water level in the tank is h. This h you have to find. There are two holes. Maybe one hole is here, another hole is here. One hole is A, another hole is B. This one is at a height h1. This is at a height h1 from the floor. This one at a height h2 from the floor. And water from here and water from here is hitting the same point on the floor. That means range value is same. Range is same. What is the formula of range? You can write here for A. For the whole A, range formula we got velocity into time. Velocity value is reflux velocity here. Reflux velocity formula will have root 2 g h. What is the value of height? What is the value of height? In the efflux velocity, the formula of efflux velocity formula is what? Root 2 gh. But small h is what? Small h is the height of the hole from the water level, from this level, from here till here, this height. This height value will come, I'm sure, h minus h1. You can write as h minus h1 into This is the value of velocity into the time. Time formula will have 2 into this value, h1 by g. 2 and 2 cancel. G and G also cancel. Your answer will come as h minus h1 into h1. This is the value of range for this one. This is equation 1. You can write here for B. Same way for B also will do the range. Range value will come here h minus h2 into h2. Equation 2. Similarly, for the whole B, the two range are equal. Therefore, from equation 1 and equation 2, these two values will be equal. You can write it h minus h1 into h1 is equal to root of h minus h2 into h2. Squaring both the sides, root will go. We'll have multiply out here. You get h1 minus h1 square. Here we'll get h2 minus h2 square. You have to make h the subject of formula. Bring h and h one side. That is h bracket common h1 minus h2 equal to, this will go that side, it will become h1 square minus h2 square. H as it is h1 minus h2, h1 minus h2 and h1 plus h2. A square minus b square formula. These two will go. You get h value coming here h1 plus h2. This is h2 plus sign plus. This is answer. This is answer. That means this height is equal to coming h1 plus h2. h1 plus h2. Then the water from each hole will be falling at the same point on the floor. So the option number C is the correct option in this question. Option C. Option C is the correct option. Have you understood? Yes. Boys? Yes, boys, tell me, have you understood? Hello? Can you hear me?
Yes, sir. Yes, sir.
Yeah, have you understood? Tell me now, have you understood or not?
Yes, sir.
I'll just give one example, okay? Suppose we are having water tanks, which is full of water, and the height of the tank is 10 meter. One example, 10 meter. If one hole you are making at 3 meter from here, and another hole 7 meters from here, the 3 plus 7 becomes 10. Then from each hole, the water will be hitting the floor at the same point. That will be happening surely. Or from a water tank, if we have 2 holes and water level will fall down, when the height of the water level becomes h1 plus h2, this position and this position's addition, at that time the water through each hole will be hitting the same point on the floor. That will happen.
Okay, sir.
I hope this problem is done. Okay. Now we are doing question on terminal velocity. Please see question number 6, page 412, page 412. Page 412, page 412, question number 6, question number 6. Calculate the terminal velocity of an oil drop of radius of the drop given, right on R. R is given 3.8 into 10 to the power minus 6, 3.8 into 10 to the power minus 6 meter, radius of the oil drop. Falling through air of coefficient of viscosity, right on viscosity value is given 1.8 into 10 to the minus 5 PL. PL we can write or Pascal second. Given the density of the oil, not the density of the medium, density of the oil is D. D is given 8 into 10 to the power of 2. 8.0, that means 8 into 10 to the power of 2 kg per meter cube. and that the density of the air may be neglected. Air is the medium in which the oil top is falling. You have to find terminal velocity. What is the formula of terminal velocity? Vt formula is 2 by 9 r square d minus rho g upon eta. This is the formula. We had derived in the morning. So now I put the value and find the answer. Very easy. Just formula based. 2 by 9. Radius is 3.8 into 10 to the power minus 6 square. D stands for density of the object which is falling down. That is oil. Density of oil is this value, 8 into 10 square. That is 100. And density of the medium in which it is falling, that is air. The density of air they are asking to neglect. Take it 0. And the value of G is 10. Eta value is given to us this much, 1.8 into 10 to the power minus 5. Now calculate in calculator, your answer will come 8.7 into 10 to the power minus 4 meter per second. This is the terminal velocity. With this velocity, the oil drop will be falling down in air. Very less slow speed. This speed is very less. Very less speed it will be falling down. But constant velocity, with this constant velocity it will fall down. Okay. So I think the same question we have in number 7, number 8, number 9, number 10. These are same formula will be used, and one thing is unknown, you have to find that. Question says determine the radius of drop. Number 7, radius you have to find. Same for terminal velocity is given, you have to find r. You can do it. Water drop falling through air. So air is the medium in which it is falling. The drop is made up of water. Then d will be the density of water and rho will be the density of air. Density of water may not be given, but we'll take it as 1,000. Density of water is 1,000 kg per meter cube. And the density of air is already given 1.21 kg per meter cube. You take it and then find the value of radius. And your answer will match. So please try these questions. If you don't get any, then ask me. Yeah. Object falling down, the object is rising. The body is rising up. That will happen. So let your answer come negative, but that signifies that the body is going up. Okay. Now we will do page 406, example 23-10. Page 406. 406. 406, example 20. Question: two equal drops of water are falling through air with constant velocity of 0.1 meter per second. Constant velocity is terminal velocity. If to form a single drop, comma, what will be the new terminal? See, terminal velocity formula is 2 drops. Now, 2 drops are coalescing together and making a single drop. So, radius will change. What was the radius of each drop in the beginning not given. But when we combine two drops, suppose the radius of each drop is 1 centimeter. When you combine them to make a single drop, what will be the radius? Can you find the radius? What is the new radius? Can you tell me what is the value of new radius? Anyone? You are having one drop, and you are combining them and getting a single drop, bigger drop. Radius of this one is R, radius of this one is R. What is the radius of this drop? Can you tell me what is the radius? Hello?
2
What is
hours.
the value of radius? It won't be 2 hours. That is what I was asking you. You had done in class 10 mensuration. Volume you have to make equal. Volume of these two will be equal to volume of this one. Then accordingly you will find. But this question we will do like this. You can't simply add the radius and get the value of radius of the bigger one. No. Velocity is directly proportional to r square. Rest of the thing is constant. We can add that is v1 by v2 ratio. Let us write. Right here r1 squared by r2 squared. Direct ratio. So first case the velocity given is velocity is given 0.1, right? 0.1, you have to find v2. Here I'll write r1 by r2 whole square. Let us find the value of this one now. r1 and r2, right? 4 pi by 3 r1 cube is equal to twice of this is equal to radius of the bigger one, 4 pi by 3 r2 cube. Like this. We are making the volume equal. 4 pi by 3, 4 pi by 3 cancelled. Cube root will go. Your answer will come 2 to 1 to r2 cube. Make r2. Therefore, r1 by r2 will come 1 by 2 to the power of 1/3. I like this value here. Write down 0.1 v2 is equal to r1 by r2 value will come this much. 1 by 2 to the power of 1/3 square. Now you find the answer. 0.1 v2. This will come 1 by 2. Cross multiply. v2 value will come 2 by 3 into 0.1. And now you get the answer. You can check the value using calculator. You can check. Your answer will come 0.159. 159 meter per second. This is answer. You will get this answer. Okay.
So not understood.
Which part you did not understand? Tell me.
So
Here I will
from starting
clarify.
only.
No problem. Terminal
The 4
velocity
pi.
and radius, how they depend. Huh?
So the
No,
4
first tell me
point-
terminal velocity. Wait. Terminal velocity and radius, how are they related to each other? Directly proportional to the square. I like ratio like this. V1 by V2 is equal to R1 square by R2 square. Now, relationship between R1 and R2 we are finding now. R1 by R2 value. So, two small drops, then it's twice the volume of each drop is equal to volume of the bigger drop. What is the shape of water drop? It's spherical, no? So let 2 into volume of the sphere formula. 2 into 4 pi by 3 R1 cube is equal to 4 pi by 3 R cube. This will cancel. So taking cube root of both the sides. This 2 will come to one side. Cube root will go. You get R1 R2. Then R1 by R2 make the subject. 1 by this will come down, and then that value I'm putting here. Okay.
Understood.
Okay. So with this chapter is over. Okay. Tomorrow we'll start new chapter, elasticity. Yeah. Okay. Thank you.
Thank you, sir.